Module 4, Lesson 3, the relationship of multiplication and addition. Learning target, we are going to continue to explore the relationship between operations in specific and general situations. We are also going to do a little bit of look at comparing expressions, in particular asking ourselves when are they equal. I-CAN statement for this lesson: I can show and explain the relationship of addition and multiplication for specific and general situations. As we've explored in the last couple of lessons, specific, we have specific numbers that we're working with. General situations, we start to step back and we're starting to use variables to represent more general situations. So your goal here is to write two different expressions. So you have a tape diagram, a model. Write an addition expression to show what's going on here, and also write a multiplication expression to show what's going on here. Go ahead and pause the video and take a moment and do that. So hopefully you looked and said we've got 3, 3, and 3 that we could represent as 3 plus 3 plus 3, because we will combine them together. And we've also got three groups of 3 for 3 times 3. So go ahead and take a look at this example. Write an addition expression and a multiplication expression to represent what's going on. So I look and say I've got 1, 2, 3, 4, 5, 6, 7, 8. I've got 8 here. And 1, 2, 3, 4, 5, 6, 7, 8. I've got 8 here. So I have 8 plus 8. And 8 times 2. Although really, I would be more inclined to say 2 times 8. I really love the meaning of in multiplication. So 2 groups of 8. Although 8 times 2 would be still 16. The answer hasn't changed. Commutative property of multiplication is kind of nice that way. I do like to think deeply about the meaning, though, 2 of 8. Take a look here at this situation. Go ahead and write your addition and multiplication expressions. So we've got 5, 5, and 5. 5 plus 5 plus 5. And we also have 3 groups of 5. So if you were in class, we'd be doing this with a partner, and each of you would build a model to represent an expression. One of you would build a model to represent 2 plus 2 plus 2 plus 2, and the other would build a model to represent 4 times 2. So go ahead and pause the video, take a moment, and build a model to represent both of these. And while you're doing that, in your head, do a little bit of compare and contrast. What do you see as similarities and differences between your models? So here are a couple of possible models. So we've got 2 plus 2 plus 2 plus 2. So that would be an addition. And we've also got 4 times 2. So we've got 4 and 4, so we've got 4 twice. Now hopefully, as you are looking at these, you are going to notice some similarities between the diagrams, which brings us to the next question here. What did you notice about the two tape diagrams you created? Now hopefully you noticed that even though the tape diagrams are representing different expressions, that they've each got the same number of squares. If we were to actually just get rid of the numbers at the bottom, they looked exactly the same. They were just 8 squares together. And this, of course, should cause a question, well, why are the tape diagrams the same? And what does that say about the value of these expressions? The value actually, when you simplify it out, when you actually do 2 plus 2 plus 2, or you do 4 times 2, what does that tell us about the value? Well, hopefully it tells us that the two tape diagrams are the same because the values are the same. There isn't a real difference here between 2 plus 2 plus 2 plus 2 and 2 groups of 4. The value is the same. They're both 8. So if both expressions give us the same value, is there an advantage of using one over the other? Does it matter which one we use? Add 2 together 4 times or do 4 times 2? That would be a good question to be thinking and mulling over. When is it an advantage to do addition? When is it an advantage to do multiplication? Or is there no advantage? So since each tape diagram has the same number of squares, can we make the statement that the 2 expressions are equivalent? And can we provide a rationale? So go ahead and pause and think about that for a moment. Try and jot down a quick answer to represent your thinking. Hopefully, as a result of your thinking, you said, yeah, these 2 expressions are equivalent because they represent the same value. There's a nice little definition for equivalent when they represent the same value. When we evaluate them, when we actually perform the operation, when we do all of this addition, we get 8. When we do this multiplication, we get 8. They are representing the same value. Now, how they get to that value is a little different. Here we're adding together. Here we're multiplying. If we were to put a real-life context with this, 2 people walked into the store. 2 more people walked into the store. 2 more people walked into the store, and 2 more people walked into the store. So we have 8 people in the store. Here you could say you've got 4 groups of 2 that walked into the store, or you could say that there are 2 groups of 4 who walked into the store. The end result is the same. There are 8 people in the store. So how we get there may be different, but in the end, the value is the same. So we can say that yes, they are equivalent. So here we go with another partner build. And since you're probably doing this by yourself, go ahead and build both of these by yourselves. So build and label a tape diagram to represent the expression of 3 times 4. I'd like to point out that this little dot here means multiply. When we start using x as a multiplication symbol, it starts to get a little bit confusing because we're not sure if that's a variable or a multiplication symbol. So you'll start to see more advanced ways or different ways of representing multiplication. So go ahead and build your diagram for 3 times 4 and 4 plus 4 plus 4. And here are some possible models. So here we've got 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 3 of 4, or we've got 4 plus 4 plus 4. So just on that one model all by itself, I've got both expressions happening, but we could also represent the multiplication in an array form. So we've got 4, 4, and 4. Maybe books on a shelf. 4 books on one shelf, 4 books on another shelf, 4 books on another shelf. So is 3 times 4 equivalent to 4 plus 4 plus 4? And can you provide an explanation? Think through how you would show and explain. Well, you've shown. You've got a model. So now how would you use words to explain if they are equivalent? Well, hopefully you would say that the 2 expressions are equivalent because each of them, when they're evaluated, they're 12. They have the same value, therefore they are equivalent. Once again, how we get there doesn't look the same. The context, the story may not be the same, but in the end, we have 12. So how could we show this using variables? How can we show an equation and a model that will give us the relationship between multiplication and addition? So stop and think about that for a minute. Scribble some notes on some paper. So here is one possible example. So maybe we've got G, G, and G. Well, this could certainly be represented as G plus G plus G, but it could also be represented as 3 times G or 3 of G. I love that of thing. So are these equivalent? How would you explain whether or not these are equivalent? And I should point out real quickly here that in this situation, and when we use variables, all of the letter G's in this expression have the same value. It would get really crazy if one of the G's could be 1 and one of them could be 2 and one of them could be 3. When we work with variables within an expression, they all have the same value. We may not know what the value is, but they all have the same value. And so, of course, this G also has the same value. Quick reminder there, each G represents the same number. So I drew you one model. Here is another model that you could look at. So here we've got just G, some number, and here we have 3 of them put together. So maybe G could be 5, in which case each of these would be 5. So here we are in a general situation. We've got just a variable, so one of them, and then we've got 3 of them. So 3G is the same as 3 times G. Notice that we're skipping the x for multiplication. It looks like a variable. That can be confusing. Write something like this. Is that 3 times G, or is that 3 times x times G? Which brings us to another discussion. When we put a number next to a variable and there's no sign, we are saying multiply them together. So when we do this, we're saying 3 times G. When we do this, we're saying 5 times A. It is kind of the same as when we use parentheses. We're saying 3 times 2. In this case, we're saying 3 times G, but we don't need the parentheses because this is obviously a variable. You can write it this way, but you don't have to. Here, if I write it without the parentheses, I don't know if it's 3 times 2 or 32. The parentheses are necessary to say, hey, this is a 3 and this is a 2, do 3 times 2. When working with variables, this is quite obviously a variable, and this is quite obviously a number, so it's 5 times A. So is the equation 3G is equal to G plus G plus G, is that an identity? Why or why not? So you need to pause and think here for a minute. What have we learned about identities? Yeah, this is an identity. Why is it an identity? Because we can replace G with any number. That's called substitution, when we put in a number for a variable. And when we do that and simplify out, the equation will be true. So for example, going back to my 5 there, I can put a 5 in there. 5 plus 5 plus 5. So I have substituted a 5 for the letter G, and this is 15, and this is 15. So that's a specific example, and of course the question is, can I put in any number that I want to for G and have that work? And we've said yes, it's an identity. So I can replace G with any number and they will always be equal. All right, so take a look at exercise 1. Write the addition sentence that describes the model and the multiplication sentence that describes the model. So this model can represent 2 different operations, addition and multiplication. Write the expression for each one of them. So 5, 5, and 5. I could do 3 groups of 5, or I could do 5 plus 5 plus 5. Exercise 2 here. So they've given us some expressions, and they would like us to write an equivalent expression. So they gave us addition here, and they'd like us to write multiplication. So we've got 6 plus 6, and they'd like us to represent that as multiplication. And my brain keeps screaming to me, hey, it's 2 groups of 6. So here we're adding a bunch of 3's together. 1, 2, 3, 4, 5, 6 of them. So I've got 6 of 3. Here we've got some 4's. 1, 2, 3, 4, 5. So we've got 5 groups of 4. And then they throw us a multiplication here. And we've got 2 ways we can think of this. If we stick with the of thing, it's 6 of 2. Add those all together. Or we could do 2 of 6. commutative property of multiplication says we can do that. All right, more of the same here. 4 of 6. Or we could do 6 of 4. One, 2, 3, 4, 5. One more. Oop. Except that would be a 4. All right, 3 of 9. Or I could write out 9 3s and add them together. Here, a little bit tricky. We've moved into a general situation rather than a specific situation. 1, 2, 3, 4, 5. So I have 5 of whatever h is. So I could write it this way. I could also write it this way, but normally this would be the preferred method right here. We could write it this way. We would not write it this way. That's a no-no. If we're going to put them together with no multiplication symbol, the 5 comes first, the variable comes second. All right, and we've got 6 y's here. Y plus y plus y plus y plus y. 1, 2, 3, 4, 5, and one more, 6 y's. All right, so Roberto is not familiar with tape diagrams and believes that he can show the relationship of multiplication and addition on a number line. So help Roberto demonstrate that the expression 3 times 2 is equivalent to 2 plus 2 plus 2 on a number line. So the first thing I need is a number line. And we're working on the positive side here, so I'm going to set 0 over here. And it looks to me like we're working in groups of 2. Everything seems to be in 2, so I'm going to count by 2's. 2, 4, 6, 8, 10, 12. 2, 4, 6, 8, 10, 12. So here we're saying 3 groups of 2. 1, 2, 3. And here we're adding 2. 2 plus 2 plus 2. So here I've got 3 times 2, 3 groups of 2, and here I'm adding 2 plus 2 plus 2. And we have demonstrated that the expressions are equivalent using a number line instead of tape diagrams or other models. All right, so now we need to do a little bit of evaluating here. We need to ask ourselves, is this equation true or false? And then give a reason. Well, I know in lesson 1 that we talked about if we add something and then subtract it away, they kind of cancel each other out. They're opposite numbers. So that would mean that x is equal to x. So if I add 6g and then I subtract 6g, it leaves me with what I started with, which is x. And x is equal to x. So here's another one. So I start with 2f. I am going to take away 4 of e, and then I'm going to add 4 of e. Well, this comes straight out of lesson 1 again also. 2f will be equal to 2f. I subtract 4e. I add 4e, which means they kind of cancel each other out. They undo each other. That leaves 2f, which is equal to 2f. So here we're going to write an equivalent expression to demonstrate the relationship between addition and multiplication. Well, I'm taking a look here, and I am seeing that I've got 1, 2, 3, 4 6's. So I've got 6 times 4, and I'm going to add that to 4 times 3. So I have taken this and equated it to this multiplication, and I've taken this and replaced it with this multiplication. Check my notes and make sure there isn't something sneakier I'm supposed to be doing there. Nope, I think that will work just fine. All right, doing the same thing here. So they've given me a bunch of addition, and that's going to be 3 times d, which I could write as 3d. I could spread it out like this, but I'm lazy. I like compact there, so 3d. And I've got 1, 2, 3, 4, 5 w's. Now you might be asking, where is he getting the plus from there? Well, the 3d is all right here. The 5 w's are here, and they are combined right there in the middle by that plus sign. So that's how I've decided I will add them together. So I'm not doing 3d 5w. I'm not multiplying all of this together. I'm combining the d's to get 3d, and I'm combining the 5w's to get 5w, and those two parts are added together by that addition symbol right there in the middle. All right, looking at the same thing here, I've got 2 a's, and there's a plus sign, and I've got 2 b's. Oh, 3 b's. I know, use the eraser. 3 b's. And I've got 1, 2, 3, 4 c's. So once again, notice, once I combine the c's, the b's, and the a's, I've got these operations in between, and that tells me what goes in between there. All right, so quick closing here. So create a diagram that models 3 groups of size b. So I need 3 groups of whatever b is. So 3 groups, and each one of them is b. So I've actually got 3b. Oh, there's one of my expressions right there, 3b. Or I can have b plus b plus b. So there's a model, there's some expressions. All right, Peter says that since the addition expression gives the same value as the multiplication expression, he'll always choose to use the addition expression when solving these types of problems. Pretty typical student response. I'm really comfortable with addition. That's what I'm going to do. Can you think of a time or a reason why doing addition may not be a good idea? Why it might be better to do multiplication? First thought that comes to my mind, what about really big numbers? What about 215b? Do we really want to add that together 215 times? That's an awful lot of work. I think it would be a lot easier to do the multiplication in that situation. And stop and think for a second here. How often have you ever added a bunch of even small numbers together and got the addition wrong? Have you ever done 4 plus 4 plus 4 and been cruising along here, and 4 plus 4 is 7, plus 4 more gives you 11, and you make one little mistake and you're off? Happens all the time. This is one of the reasons we have more efficient ways of doing things so that we can eliminate the opportunity for errors. All right, so quick look at our I can statement. So hopefully you can show and explain the relationship between addition and multiplication. Hopefully you can do that with specific situations. So 3 plus 3 plus 3 and 3 times 3. And hopefully you can do that for general situations. Starting to throw in these variables here. So we've continued the exploration of relationship between operations in specific and general situations, and we have also done some comparison, in particular focused on equal expressions. So at this point, if you've got any questions, get a hold of your teacher, talk with them. Go ahead and complete your problem set. That concludes Module 4, Lesson 3.